Okay, we're now going to talk about linear and nonlinear systems of equations, and we're really going to just be talking about solving these. Now, this is something you may have encountered before, but solving systems of equations is a very useful skill to have, and in this section here, we're going to talk about when we don't necessarily have two linear sets of equations. In the next sections, we'll talk about what happens when you have two sets of linear equations. So, if we want to talk about what this is, as far as when you're solving these, if you imagine that we have two systems of equations, for instance, let's just look at an example here, where the system of equations is 3x squared plus 4x minus y is equal to 7, and then 2x minus y is equal to negative 1. Now, I'm not going to sketch these to scale by any means here. I'm just going to get it here. But if we solve, we're not going to, but if we solved this equation for y, both of these, we would be able to graph this. And the first one would be graph of a parabola opening up. So I'll draw a graph of a parabola opening up. And then the other one is a straight line. And so we'd have a straight line here like this. And so when we solve these, what we're really going to be finding is these points of intersection, where these two equations or curves are intersecting. So when solving a system of linear and nonlinear equations, this is what we'll be finding. So how do we do this? Well, the primary method we're going to focus on is the substitution method in this video. And the substitution method is kind of what it would imply is we're going to do substituting one equation into another. And basically we're going to solve one equation for x or y, then substitute this into the other equation. And then we'll simplify and solve. Now when it says solve one equation for x or y, the reason I say x or y is it doesn't matter which one we do, and it doesn't matter which equation we solve. But if I look here, I might pick this equation right here to solve, and I'd probably solve it for y. And the reason I would do that is that's actually going to give me a really simple equation for y. So let's go ahead and do that. So I have my equation 2x minus y equals negative 1. Then I'd add y to both sides. So you have 2x is equal to negative 1 plus y. And of course, adding 1 to both sides, you'd have 2x plus 1 is equal to y. So I've solved that bottom equation for y. Now what I'm going to do is I'm going to take this equation here, the 2x plus 1 equation, and substitute it up into this equation. So what do I have here? I have 3x squared plus 4x minus y equals 7. So again, what am I going to do? I'm going to take this, and this is where the name substitution comes in, and substitute it in here. Now, a common mistake people make is they forget to use parentheses, and then they lose negatives and all sorts of other things. So 3x squared plus 4x minus the quantity 2x plus 1 equals 7. Then we'll just go ahead and simplify that. So we have 3x squared. I'd have plus 4x minus 2x, so that would be plus 2x minus 1 equals 7. Now this is a quadratic equation. It's 3x squared plus 2x, subtract 7 both sides, minus 8 is equal to 0. And you could go ahead and use quadratic formula if you wanted to, but just staring at this for a few minutes, this actually does factor. And the 3x squared is easy because this would be 3x. And you could even use the rational root test and everything. But 3x squared is only going to factor if it's something that's easily factored. It can only be 3x and x. And then if we just play around here, we can see if I do plus 2 here, the outside would be plus 6x, and if I do minus 4, it'd be minus 4x, and so, well, negative 4 times 2, negative 8, 6x minus 4x, of course, is 2x, and this is still equal to 0. Now, when we solve these system of equations, it's not just good enough to get x, we need to know what x and y are. So we can get here that 3x minus 4 equals 0, and of course that x plus 2 is equal to 0. So then solving this, you'd get x is equal to 4/3, or x is equal to negative 2. Now we have to figure out what y is. Now, figure out what y is, all you have to do is plug x into one of the equations. To find y, substitute x into either equation. Now let me scroll back up to the start of this problem here. Remember, these are the two equations we're looking for, and we're going to have to find y. Well, we can plug x into either of them, but the one that makes the most sense, in my opinion, would be the second one. Why? It's the easiest equation. It's got the least amount of computations that I have to do. In fact, I've already solved that one for y. I know that y is equal to 2x plus 1. So y is equal to 2x plus 1. And so you'd have y is equal to 2 times 4/3 plus 1, which is 8/3 plus 1, which would be 11/3. And then we also have y is equal to 2 times negative 2 plus 1, and then y is equal to, arithmetic's failing me here, negative 3. So my solutions are 4/3, comma 11/3, and negative 2, comma negative 3. So solutions to these are going to be points, as again, if you just think about the graph we drew here, we would have points that we are looking at. Okay, well let's look at another example here. Let's look at the system of equations. 2x minus y equals negative 3. And then 2x squared plus 4x minus y squared equals 0. Now again, we pick either equation and we solve for either x or y. Now again, I think it's pretty obvious the one I would pick would be the top equation, and I would still solve that for y. So I've got 2x, let's see here, maybe, there we go, 2x minus y equals negative 3, and then I'm just going to solve this in one step, adding y to both sides and then adding 3 to both sides. You get y is equal to 2x plus 3. Alright, now we would take this, substitute it in here, so we're going to have 2x squared plus 4x minus the quantity 2x plus 3, quantity squared, equals 0. Again, notice how anytime I substitute in, I put it in parentheses to make sure that I do all of the steps that I need to. Now, of course, I am going to have to multiply out and simplify. So this would be 2x squared plus 4x minus, I'm going to use my special product formula. So this would be 4x squared plus 12x plus 9 equals 0. And then I have 4x squared minus 2x squared minus 4x squared. So I have negative 2x squared. I've got 4x minus 12x, which would be minus 8x. And then I have minus 9 equals 0. Now I'm going to go ahead and multiply through by negative 1 because that will make everything positive. And this one may factor. I've stared at it for a few minutes and I just don't see an easy factoring on it. And so let's go ahead and use my quadratic formula. So x would be negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 9. And this is all over 2 times 2. And so x would equal negative 8 plus or minus the square root of 64 minus 72 over 4, which is equal to negative 8 plus or minus the square root of negative 8 over 4. But wait a minute, what do we have right now? We've got that this is imaginary. So technically there's a solution, but it's a complex solution, and we're not really interested in those right now. So this has got no real solution. Okay, so it's got no real solution, but what does that mean as far as a graph goes? Well, it means as far as a graph goes, there wouldn't be an intersection on these points here. Now, as far as what this graph would look like here, now these aren't functions, because the second equation is not a function, but just to give you a rough idea, the second one, we have basically, I think it would look something like this here. It's a conic, it's an ellipse. So an ellipse, and then the line y equals 2x plus 3 is going to be maybe somewhere like this. So this is the one equation ellipse, and all this means, because I got complex solutions, was that I have no intersection. So it's possible to get no solution. Another example of getting no solution would be if your variables disappear and you get something that doesn't make sense. And what I mean by doesn't make sense, if you get like 3 equals 4. 3 equals 4 doesn't make sense. And so that would be another case where there's no solution. All right, let's look at one more here before we wrap this up. And honestly, this topic of solving systems of equations here, this kind of wraps up the linear and nonlinear. We're then going to focus on the linear case because those do come up quite frequently in the next video. So let's look at an example here, another one. Let me pause it. So let's look at this one here. So we've got x minus 2y equals 0, and then 3x minus y squared equals 0. Now I want to do this one, not because it's any more challenging than the other ones we've done, but if we look at this, I'm going to probably look at the first equation here, but instead of solving for y in this case, I'm going to solve for x, because I have x just by it, just 1x here. So I'm going to have x minus 2y equals 0, and then I'd have x equals 2y. And then I'm going to substitute that into my other equation. So if I substitute that into the other equation, you'd have 3 times 2y minus y squared equals 0. And then, of course, distributing it, we'd get 6y minus y squared equals 0. And then let's go ahead and factor here. Well, y times 6 minus y is equal to 0. And this clearly gives me that y equals 0 or 6. Now, we can just simply figure out what x is, again, by knowing that we've already solved and have that x is equal to 2y. And so we'd get that x is equal to 2 times 0, which is 0. And then also x is equal to 2 times 6, which is 12. And so my solutions, now make sure to put them in the correct order. It's 0, 0, and then the x value is 12 and the y value is 6. Now, I'm going to go ahead and kind of scroll back up here and put my solutions here as 0, 0 and 12, 6. Now, we haven't done this before, and on this last example I think I just illustrated. How do you know if your answers are right? Well, you can always check your answers just like you would always check your answers on any kind of solving equations. You can always substitute back in. Now, in this case, you just have to substitute x and y, but it has to satisfy both equations. So if we do the first one with the 0, 0, of course we have 0 minus 2 times 0, which that's equal to 0. Okay, so that checks out. And then we have 3 times 0 minus 0 squared, which is also still 0, so that checks out. So that means, because both of these are true, that means 0, 0 is a solution, that we didn't make a mistake. Now let's check 12, 6. So we have 12 minus 2 times 6, which is of course just 12 minus 12, which is 0. So that checks out. And then the other one, we'd have 3 times 12 minus 6 quantity squared, which would be 36 minus 36, which equals 0. And that one checks out. So you can still check your answers by substituting in. The only difference here is that you actually have to verify that the answer you have works in both equations. Because again, the whole point is, if you look at the graphs of these equations, you are actually getting the intersection points on the graphs. Alright, that will wrap it up for this video, and as I said, we'll move on to just linear systems in the next video.